Hello guys, welcome to this Reasoning with O1 course. What if we told you that there's an AI that does not just give answers but actually thinks? So introducing O1, the latest and the most advanced reasoning model from OpenAI. So unlike other models that rely on patterns, O1 is designed to reason through problems, self-correct and explain its thinking step by step just like a human would. So, today we will explore what makes O1 so special. Then we will come across how it reasons. Then we will see where it's useful, and finally we will see why learning about this model is essential in the age of intelligent machines. So let's just dive in. So what is O1? So O1 is OpenAI's new AI model. But it's not just a smarter chatbot, it's a reasoning engine. While models like GPT-4 are brilliant at language and creativity, O1 gives a step further. It can think logically, it can solve problems with multi-step reasoning and analyze the complex data. In short, O1 is the closest we have come to building an AI that can think through a task, not just respond. So why does this matter? Because the real world problems in maths, science, code and life require structured thinking, not just quick answers. So let's now move on to what is reasoning and why O1 needs it. So before we understand how O1 works, let's ask what is reasoning. So reasoning is a process of analyzing information, finding connections and drawing conclusions, like solving a puzzle. For example, you see dark clouds. People are carrying umbrellas, so even if it's not raining, you reason it as it's about to rain. So AI needs this same skill. So without reasoning, an AI is like a parrot. It repeats. With reasoning, it becomes a problem solver. And that's exactly what O1 brings to the table. So let's now understand how O1 reasons. So let's break down how O1 actually reasons step by step. The first one is chain of thought reasoning. So O1 solves problems step by step just like we do on a paper. For example, the question is, what is 12 into 15? O1 does not just say 180. It thinks it as 10 into 15 is equal to 150. Then it calculates 2 into 15 is equal to 30. Then it adds final two results, that is 150 plus 30 is equal to 180. So this chain of thought method reduces errors and shows the logic behind every answer. So let's now move on to the next, that is reinforcement learning. So O1 gets better over time by learning from success and failure, just like a person. If one method doesn't work, it tries another, sees the result and improves next time. It's like a chess player who gets sharper with every game. Then we'll come to reasoning tokens. So when O1 solves a complex task, it uses invisible tokens to keep track of its thoughts, like a mental sticky notes. So imagine solving a math problem. You scribble your steps on a paper. O1 does the same internally, helping it to stay organized and accurate. So let's now dive into the real life examples. So let's see O1 in action. The first one is solving a math problem. So the question is, what is 25 plus 37? So O1 thinks like 20 plus 30 is equal to 50. And 5 plus 7 is equal to 12. 50 plus 12 is equal to 62. And the final answer it gives is 62. So it's not magic, it's methodical reasoning. That's what makes O1 more trustworthy and transparent. Then we are going to the next example, that is debugging a code. So now let's shift to a coding scenario. If you ask, why is my Python code giving me an error? So here's what O1 does. It reads the code line by line, spots where the error happens, then explains why it occurred, and then it suggests a fix step by step. It's like having a calm, logical coding partner who always explains their thinking. So let's now move on to the next one. We have what makes O1 different. So here is a quick comparison. Say we have a capability. So GPT-4 predicts the next word, and same O1 also does. So GPT-4 thinks through steps. It doesn't think through steps, but O1 does. So GPT-4 self-correction is a basic thing, but the self-correction in O1 is a very advanced thing. Then it solves the complex problems. GPT-4 sometimes does it, but O1 is consistently doing it. Then transparent reasoning. GPT-4 has no transparent reasoning, but O1 has a transparent reasoning. So let's move on to where can O1 be used. So because of its structured reasoning, O1 is useful in multiple domains. The first one is maths and science, solving equations, explaining experiments, and so on. And then we have coding, so writing, debugging, and understanding programs. Then we have research, that is analyzing data, summarizing papers, and verifying facts. And then we have creative work, so planning content, brainstorming logically, are all falling under creative work. Then we have image analysis, this interpreting visuals step by step. So wherever thinking is needed, O1 delivers clarity. So let's now come to the common mistakes avoided by O1. So previously, older models had a few common issues, such as the jumping to conclusions directly, then ignoring small details, and then we have repeating errors in the new context. But O1 avoids all this by reasoning in steps, checking its own logic, and learning from feedback. And that's why it's more dependable, especially when stakes are high. Let's now move to why O1 is so important. What is the future of work and thinking? So because reasoning AI is the future and it's already here, learning OI works helps you use AI more effectively. Ask better questions, obviously, then understand how machines think, and then stay ahead in the technical, research, and educational field and become a critical thinker yourself. So this is not just about AI. It's about preparing for a world where thinking with AI is a part of how we work, learn, and create. So let's now move on with the key takeaways. So let's recap what we have learned. O1 doesn't just answer, it reasons. Then it learns from mistakes and improves. It explains its logic step by step. Then it's accurate, explainable, and helpful across industries. Then it's future of intelligent systems and you can be a part of it. So whether you are a student, developer, analyst, or just curious, O1 is just a tool that helps you think better. So let's dive into deeper in the next module. Hello guys, welcome back to the second module. So in this module, we will learn about promptings in O1 models. So prompting is a way we interact with the AI by giving instructions and receiving responses. So with O1 models like GPT-4o, things have gotten simpler. So these models understand prompts with more accuracy, which means you can be clear, concise, and direct without over-explaining. So there are certain principles of prompting in O1 models. The first one is it is simple and direct. Then number 2 is no explicit chain of thought needed. Then the third one is structure over description. And the fourth one is show, don't tell. So there is a summary for this. Like to get the best out of the O1 models, remember these 4 principles. You have to be simple and direct. No need for explicit reasoning. It's already built in. So give structure, not long descriptions, and show tone with examples. Don't just tell. So these principles will help you get better, faster results from O1 models while keeping things smooth and efficient. So let's then get into the demo part. So here we'll write our first code as. So the first thing, import warnings, warnings.filter warning, ignore. So this is basically a warning control. So this is a Python code snippet does 2 main things. It suppresses warnings and retrieves the OpenAI API key for use in the later interactions. So I will just break it down step by step. So the first line, import warnings, imports Python's built-in warning module. So this module is used to manage the warning messages in the program, which are typically notifications for the potential problematic or unexpected events in your code. It helps developers keep track of the minor issues without even interrupting the program's execution. So next, warnings.filter ignore is used to tell Python to ignore any warning messages that might appear. So normally warnings are shown to alert the developer about something so that may be critical issue but could be important. So then the third line from helper import get OpenAI API key imports a function called get OpenAI API key from a module named helper. So this function is responsible for retrieving the OpenAI API key, which is necessary for interacting with the OpenAI services, such as generating text or using other machine learning models. So finally, the OpenAI API key is equal to get OpenAI API key calls the imported function to get the API key and stores it in the variable OpenAI API key. So these variables know how the key needed to access the OpenAI's features, and it can be used for even making the authenticated API request. So this code is designed basically to suppress any unnecessary warnings while ensuring that the program has the power of the API key. So let's just run this. So then basically we have imported JSON. So the firstly, import JSON allows working with the JSON data, obviously, commonly used in the API interactions from ipython.display, import display, then markdown HTML, imports functions to display, etc. So then from OpenAI, import OpenAI imports the OpenAI class, so which is used to interact with the OpenAI services. Then client equal to OpenAI API key equal to OpenAI API key creates an OpenAI client using the API key, enabling communication with the OpenAI's models. Then finally we have GPT model equal to GPT-4o mini and O1 model is equal to O1 mini. Defines the name of the two different models that can be used in the API requests. So in short, this code sets up the OpenAI client and defines the two models for use in natural language processing tasks. So we'll run this. So here basically the code snippet defines a prompt for generating a function using the OpenAI's model. Then sends the prompt to the OpenAI API to get a response. So let's now break it down step by step. So bad prompt equal to generate a function till insulin creates a string variable called the bad prompt because it is a statement basically. So this prompt is a request for the model to generate a function that outputs the smiles IDs, a way to represent the molecular structure basically for all molecules involved in the insulin. It also guides the model to think step by step, outlining tasks like identifying the models, creating the function and looping through each molecule to return the smile IDs. So then we have response equal to client.chat.completions.create model. So this basically sends the prompt to the OpenAI API for processing. It uses the client.chat.completions method to interact with the OpenAI's API, specifying the model, that is O1 model, which was defined earlier. The messages parameter sends the bad prompt to the model as input under the user role. So in short, this code defines a prompt using the OpenAI's model to create a function for returning the smiles IDs for insulin molecules and sends that prompt to the OpenAI API to generate a response. So let's now move on, run this and move on. So then basically we have display HTML division style equal to background color. So basically displays the formatted HTML and markdown content in a Jupyter notebook. So then we have the first version, the first line, displays an HTML division with a light background color and a border also. So it also includes a heading that says markdown output beginning with a downward arrow emoji. Basically, the HR tags are used to insert the horizontal lines before and after the heading. Then we have display HTML function is used to render this HTML in the notebook. Then we have display markdown. This line takes the content of the response from OpenAI's model stored in this and it displays it as markdown. The markdown function is used to render the content in a more readable formatted way. So this content could include text, headers, list or any markdown elements generated by the model. So then we can run this and you can basically see the heading. Then the step 1 is identify all the molecules involved in insulin, chain A, chain B. Then step 2, prepare the smiles and strings for each amino acid. Then we have create the function. This is basically the output. So then we have this good prompt, generate a function that outputs a smile IDs. As we have given a bad prompt, it is necessary to give a good prompt as well. So yeah, we have given a good prompt. So let's now display that good prompt. Mark out beginning, understand insulin, step by step. And you can see the difference clearly. So this is basically a great code, but don't get overwhelmed. I'll break it down step by step. So this example is a structured prompt basically and used to guide an AI assistant to behave like a customer service representative for a company named Any Corp. So which sells storage solutions such as beans. The purpose of this prompt is to make sure that the AI behaves professionally, respectfully and in line with the company policies while responding to the customer queries. The first part of the prompt, labeled as instructions, clearly tells the assistant what role it is playing, a customer service assistant, and emphasize the tone it should maintain kind and respectful at all times. So this ensures the assistant responds in a friendly and helpful manner, just like a real support agent would. So next comes the policy section, which outlines the 6 specific areas that the assistant must follow. So these include handling refunds, recording complaints, providing accurate product information, maintaining the professional conduct, complying with the policies and data privacy rules, and refusing to answer questions outside these topics. For example, under refunds, the assistant is allowed to process them as long as it follows Any Corp's rules and documents everything properly. If a customer complains, the assistant should listen carefully, reassure them, and escalate the issue if necessary. So if asked about topics unrelated to these areas, the assistant must politely refuse to answer and guide the user back to the allowed topics. The final part is a user query, which shows the customer's actual message like, hey, I would like to return the bin I bought from you as it was not found as prescribed. So these falls under the refunds category in the policy. Since the assistant is allowed to handle the refund request, it will process this message accordingly, possibly by confirming the issue, starting the return process, and recording the complaint. So in short, this structured prompt creates a safe and clear framework for the assistant to operate. It tells the AI what kind of support it can offer, how to behave, what topics are allowed, and how to respond when faced with customer issues, all while making sure the customer feels heard, respected, and healed. So let's now print the statement, the structured prompt. Now you can see that it is printed. So now this code is from the Python program using the OpenAI API, which allows developers to interact with the AI models like ChatGPT. So especially this line is used to send a prompt to the AI and get a response back. The function call is then client.chat.completion.create. So client is the OpenAI API client that was likely used up earlier in the code. It connects your code to the OpenAI server. So the .chat.completions.create part is how you send a chat message to the AI and ask it to complete the conversation. So in other words, generating a reply. So inside the parenthesis, the first argument is model is equal to O1 model. So this tells the API which version of the AI model to use. For example, GPT-4, GPT 3.5 Turbo, or some other customer or fine-tuned model stored in the variable. So this ensures that you are using the right AI brain for your task. So the second argument is messages again. So this is where you pass the actual conversation history or input formatted as a list of message objects. So in this case, there's only one message in the list and it has two key parts. The role, that is the user, then the content, it is a structured prompt. The role, the user, so this tells the AI that the following content is coming from the user, so not from the system or assistant. And the content is the combines the earlier structured prompt, so which include instructions and policy rules for the assistant with the user's questions like wanting to return a bean, etc. This combined content acts as the full message the AI will read before replying. So in more simpler terms, this line is telling the AI, hey, you're a customer service agent for any crop. Here's your policy. Now here's a customer question. What will be your reply? The AI will read the whole input, follow the instructions and policies, and then return a customer-friendly response. So the response itself will be saved in the variable called response, which you can later print or process in your code. So let's run this. So I have this printed response. So I will just run this. You can see the response basically. Then we have this refusal input. The variable refusal input contains a user query that asks the AI, write me a haiku about how reasoning modules are great. So this is wrapped in XML-like tags. This purpose of this input is to test the AI's ability to say no. According to the structured prompt and policy you provided earlier, the assistant is only allowed to talk about refunds, complaints, and product information about the storage solutions. A haiku about reasoning models doesn't fall into any of these topics. So when this refusal input is combined with the structured prompt and sent to the AI, it should politely refuse to answer and explain it so it can only help with the allowed topics. We will run this. So again, this line is sending a new message to the AI model, but this time using refusal input instead of user input. The client.chat.completions.create calls the OpenAI API key to get a reply from the AI. Then model is O1. Model tells which AI model to use. Then messages we have is sends a message to the AI with. Then here the role is a user and the content is structured prompt plus refusal. It basically combines the rules of the structured prompt with a new question that may be outside the allowed topics. Since the structured program says that the assistant must refuse questions outside refunds, complaints, product information, these test checks if the AI correctly refuses to answer. So in short, this line tests if the AI follows the policy and politely refuses to answer the question it's not allowed to handle. So let's run this. So this line basically displays the AI's reply to the refusal input. You can see that this is the output. So now we are ready for giving up for a base prompt and a legal query. So let me explain. The variable base prompt is used to define the role and the behavior of the AI assistant. So in this case, the AI is told to act as a lawyer who specializes in the competition law, especially helping the business owners understand the legal issues. So this prompt is wrapped in tags like prompt and policy to make it structured and easy for the AI to interpret. So the policy section outlines the important rules the AI must follow. It says that the assistant should give clear and accurate information about the competition law, maintain confidentiality and professionalism, and avoid the offering specific legal advice unless there's enough context. The legal query variable contains the actual question from the user. The query is, a larger company is offering suppliers incentives not to do business with me. So is this legal? So this is wrapped inside a query tag which keeps the input structured and consistent with the rest of the prompt format. So in summary, this setup gives the AI a clearly defined role as a legal expert and a policy to follow. For example, we will now run this. So this line then sends the structured legal question to the AI using the OpenAI API. The goal is to get a helpful and professional response from an AI that's acting as a competitive law expert. So the method client.chat.completionScreate is used to generate a chat response, as we have discussed earlier. Here the role is a user and the content is base prompt plus legal query. So we'll now run this. So now we are going to visually display the AI's response with styling and format, and it helps the output look clean and organized for the user. So we'll do this, and you can see it is a step-by-step guide for the. So this is also again a like BigQuery. So here the variable example prompt is a structured example prompt that shows how an AI assistant acting as a competition law expert should respond to a user's legal interest. So it's formatted using special tags like prompt, policy, example, question, and response to keep everything organized and machine readable. So inside the prompt section, the AI is structured to behave like a lawyer who specializes in the competition law, helping business owners with their legal questions. So this gives the AI its role and sets the stage for how it should respond. The policy section defines the boundaries the AI must follow. Then we have the example section provides a sample legal scenario and how the AI should answer. So then we have the response that follows is a well-structured professional reply. It begins by referencing the US antitrust laws, especially the Sherman Antitrust Act, and explains how some types of collaboration like price fixing or market division are automatically illegal. So then we have it also warns the information sharing, which can be risky and potentially lead to antitrust violations. In summary, this example prompt acts as a guide or training example to show how the AI should behave in legal conversations. So then I'll run this. So here then we are going to again display the output in a formatted style, and you can see this displayed. So let's now move on to the next module and learn about planning with O1. So in the earlier lessons, we explored how to structure prompts and guide the AI models like O1 and O1 Mini to behave in specific roles. So whether a customer service agent or a legal advisor. So here in this lesson, we will learn how to plan with O1. It will introduce a powerful use case where the AI is not just answering a single question, but actually creating a full plan to solve a task. So this kind of problem solving is perfect for O1 models, especially when you are working with a fixed set of tools and some constraints. So instead of asking the model to do every step directly, which could be slow and expensive, we let O1 Mini generate the plan and then use a smaller, faster model like GPT-4o Mini to execute its step. So this two approach, planning with O1 Mini and executing with GPT-4 Mini, helps us work efficiently. So please don't worry if your results don't exactly match the ones in the video tutorial now. That's totally normal since AI responses can vary slightly every time you run them. So in short, this lesson builds on what you have already learned and now takes it a step further, like teaching the AI how to think ahead and plan, not just react. So let's dive in. So we will start with the first part of the code. This is about suppressing the warning messages as we have discussed earlier in Python. So Python sometimes shows warnings when it deflects something that might not cause an error right away but could lead to issues in the future. So this is for this. And the second part is focused on importing your OpenAI API key securely. So instead of hard coding the key directly into the notebook, which is not safe, the code calls a helper function. From the helper import getOpenAI API key brings in a function named as getOpenAPI key. So we will run this. First two lines import the two standard Python modules, copy and JSON. The copy module is used when you want to duplicate the Python objects, especially when you need to make changes without affecting the original. The JSON module is used for working with the JSON data, which is common format for sending the receiving structured information, especially when dealing with the APIs. The next line imports the OpenAI class from the OpenAI package. This is what allows your code to communicate with the OpenAI's language models like GPT-4 or O1 Mini. Then we import the O1 tools from a separate live named utils.py. So this likely contains some common utility functions or tools. So then next we set up the connection to the OpenAI's API by creating a client instance. So client equal to OpenAI API. Here the OpenAI API key variable, which was retrieved earlier using the get OpenAI API key, is passed to authenticate your session with the OpenAI. So this line sets up the client object which you will use to send prompts and receive responses from the models. So finally, two variables are defined to specify which models to use. So these are simply model name shortcuts. So instead of writing the full model name each time, you can just refer to O1 model and GPT model. So O1 mini is used for planning the task, while GPT-4 mini is likely used for executing the individual steps in the plan. So we will run this. So here the code first line initializes an empty list called message list. So this list will likely be used to store the sequence of messages exchanged with the AI model. Next we define a dictionary name known as the context, which sets up the initial state of a business environment for a planning task. Under the inventory section, we are told that 50 units of the Smart Home Hub X200 are currently in stock. Then under the orders, we see a single order that is 0RD3001 requesting 200 units of this product for a customer that is having the ID CUST9001 located in the LOS Angeles. The available suppliers and the supplier section list two suppliers and the components they can provide. Notably, only SUTT1001 has a component of COM X200 required to make the X200 product, and they have 500 units available. The product capacity then section defines how many units can be produced. 100 right away and another 150 next week. This helps the model decide how to meet the demand of 200 units. The shipping options provide two choices for delivering to Los Angeles: a standard service that costs $1,000 and takes 5 days, an express service that costs $1,500 and takes only 2 days. The model can consider this based on the urgency or budget. The customer's dictionary holds customer details like the name and the address of the client placing the order. The product section defines what components are needed to manufacture each product. So in this case, the X200 device requires 1 unit of COM X200 to build each finished product. The code sets up a realistic business scenario basically involving the product inventory, orders, manufacturing, suppliers and shipping, all the key elements the AI needs to plan how to fulfill the order effectively. So we'll run this. So this is basically a prompt for planning the task. So this block defines a large string called the O1 prompt, which acts as an instructional prompt for an advanced language model like O1 Mini. The goal of this prompt is to guide the model to act as a supply chain management assistant and generate a detailed logical plan for handling a complex order fulfillment task. It's essentially the brain that will break down a business challenge and outline the best steps to solve it. The first paragraph in the prompt sets the context. It tells the AI that it will be given a complex task that involves managing customers' inventory, production, supplies, and shipping. The next section lists all the functions available to the executor AI. The functions allow the executor to do things like check inventory levels, allocate stocks to the orders, place purchase orders with suppliers, schedule production runs, and so on. Each function is briefly described along with its required inputs and expected outcomes. So this ensures the planning AI knows what tools are available, how they work, and what each one is for. It helps the model build a plan that is realistic and executable by the downstream agent. So in summary, this O1 prompt sets up a rich and highly structured instruction environment for the planning model. It tells the AI to think carefully, reason step by step, and create a clear, detailed, and logical ordered plan. One that another AI can confidently execute using the provided tools. It ensures consistency, safety, and clarity across every step of the supply chain process. So let's run this. So this is basically the prompt for the execution process by the system. So this block defines a variable called GPT-4o system prompt, which is a string used to guide the behavior of the execution model, especially the GPT-4o mini. In this case, while the O1 mini model is responsible for planning, the prompt is for the model that carries out each step of the plan. The assistant is told as to act as a helpful executor whose job is to strictly follow a given policy related to handling incoming orders. The prompt defines a step-by-step workflow for the model to follow. First, the model should read and understand the full policy. Then it needs to identify which step in the policy is currently working on. So before acting, it should give a brief explanation of the decision. So finally, it should perform the action, which typically involves calling one of the available functions with the correct inputs. So in summary, the GPT-4o system prompt sets up the mindset and the behavior of the GPT-4o mini executor. It ensures the model works step by step, explains its reasoning, and only takes action that match the policy, creating a controlled and a transparent execution flow for order handling in a supply chain scenario. So let's now do this. This code block defines a list named tools which contains a collection of the functions that AI can use to interact with the supply chain system. So these functions act like a toolbox, and each tool or function performs a specific task related to the inventory, production, suppliers, orders, etc. So each tool is defined as dictionary that includes its type, that is the function, and a function section that deals the function's name, description of what it does, and the input parameters it expects. Some key functions include get inventory status to check how much a product is in stock, then update inventory to add or subtract stock, then fetch new orders to see which orders are pending, then get product details and check available suppliers to explore what's needed to make products or find suppliers. Then place purchase order to order components. Allocate stock to reserve product for a customer order. Check production capacity and schedule production to plan and carry out manufacturing. Then calculate shipping options and book shipment to handle delivery. Send order update to notify the customer. Instructions complete to mark that all steps in the plan are finished. So each function also defines the parameter it requires, like product ID, order ID, and quantity, etc. So this is important because AI must pass exactly the right data when calling these tools. The use of required fields and the additional property. So in summary, the tools list defines a complete set of functions the AI agent can use to operate the supply chain system. So let's now move on to the functions then. So this block defines all the Python functions that simulate the supply chain operations described earlier. The first few functions deal with the inventory management, get inventory status, then get product details. This fetches the product information, then get inventory status returns how many units of a specific product are currently in stock, then update inventory product ID quantity change, adjust the inventory count based on a positive or negative change, making sure inventory doesn't go below 0. Then allocate stock, tries to reserve the inventory for an order. If there's enough stock, it reduces the inventory and confirms the allocation. If not, it allocates whatever is available and marks the result with an insufficient stock warning. The supplier related functions start with the check available suppliers, which returns a list of the suppliers the company can order components from. Then comes the production related logic. Check production capacity, time frame checks how many units can be produced with the given time frame. Then schedule production run checks the capacity, schedules program if possible, and updates the inventory. For shipping, the function calculates shipping options, returns a list of available shipping methods and their cost for the specified destination. Lastly, the function send order update simulates sending a message to the customer to keep them updated on their order status. So at the very end, there's a dictionary called function mapping, which links each function name to the actual Python function. So let's then run this. So guys, knit together the whole process and make the most out of it. Let's now move on to the next module. Hello guys, welcome back to this new module of coding with O1. So initially we will start with the first part that hides the warning messages using the warnings.filter warnings ignore as we were using to. So this keeps the output clean by preventing the non-critical warnings from appearing during execution. Next, the code imports get OpenAI API key function from the helper file. Finally, the function is called and its result is stored in the OpenAI API key variable. So in short, this setup hides warnings and securely loads your API key for using OpenAI tools. So we'll run this. So here then the first line imports the three useful display tools from ipython.display, display image and markdown. These are commonly used in Jupyter notebooks to visually show images, format output using markdown or display objects in a cleaner way. Next, the code imports the OpenAI class from the OpenAI library. So this class is used to create a client that communicates with the OpenAI's API to generate responses, run models, or perform other AI tasks. So then the client is equal to OpenAI API key. OpenAI API key initializes the OpenAI client using the API key we previously stored. So this connects your code to the OpenAI services so you can start making the API calls. So finally, two variables GPT model and O1 model are defined with model names GPT-4o mini and O1 mini. These are likely short and labels are used in your code to specify which AI model you want to work with when making the API request. So we'll run this. So this code defines a function called getChatCompletion, which is used to get a response from an OpenAI chatbot model. It takes two inputs, the model, the name of the model you want to see like GPT-4o mini, and prompt the user's message or question. So inside the function it calls client.chat or completion.create. So this is the OpenAI API method used to send the prompt to the chosen model and generate a chat-based response. So the message is passed in the format OpenAI expects an array of message objects with the roles like user and assistant. Finally, the function returns just the content of the model's reply using the response.choices.message.contain. So this keeps the output clean and gives you only the AI's reply text, not the entire API response structure. So we'll run this. Now here the code defines a multi-line string variable called the React demo prompt. So it's a prompt written in the natural language that will be sent to an AI model like ChatGPT to generate a React component. The prompt is asking the AI to create a React component named feedback form for collecting structured interview feedback. It outlines four main requirements: rating candidates with rubrics, giving specific evidence for each rating, auto-calculating a recommendation score, and guiding the interviewer to provide the behavioral feedback. It also includes additional instructions for the AI, like using the intelligent UX features like thoughtful rubrics, smart validation, and helpful prompts. Finally, the prompt includes clear coding instructions. The component must begin with the use client. In short, this prompt is designed to generate a polished, intelligent interview feedback from using React. So, we'll run this. So, this line calls the getChatCompletion function, which was designed earlier to get response from the OpenAI model. It passes two arguments, GPT model, which specifies the AI model to use like GPT-4o mini, and React demo prompt, which is the detailed instruction asking the model to generate a React component. The function sends this prompt to the model and returns the AI's response, which will be block of code as requested. The result is then stored in the variable called GPT code, which now holds the React component code generated by the AI. So we'll run this. So let's now simply print the code, and you can see the code is printed. So this line uses the display function from the ipython.display to show an image inside a Jupyter notebook or similar environment. So image GPT-4 app, you can see this. Image GPT-4 app image loads an image file named GPT-4 app image.png from the current directory. Together, this command displays the image in the notebook output, which can be useful for showing the visual results, UI screenshots, or diagrams alongside your code. So let's now move on. So it now sends the same React demo prompt to a different model called the O1 model, which is likely a lighter or experimental version like the O1 mini. It uses the get chat completion function to generate the code by calling the OpenAI API. Now O1 holds the output generated by the O1 model for the same prompt, allowing you to compare the results across models. And you can just print the O1 code, and you can see now it is printed. And you can now display this. Now this is nice. And with this, the function process orders text in a list of orders and optional parameters, settings, debug, and notify customer. So it processes each order by validating its fields, calculating totals, applying discounts, and queuing the customer notification. It collects the results, errors, and notifications in a separate list and returns them in a dictionary. So however, these are the few issues in the code. First, using a mutable default argument settings is risky because it can lead to unexpected behavior. It's better to use none and assign an empty dictionary inside the function. Also, comparisons like if debug is equal to true should be simplified to if debug. Similarly, if items valid is equal to true can be just if items valid. So in short, the function logic works for basic order processing but should be cleaned up for the Python best practices, performance, and maintainability. So let's now run this. So basically it creates a prompt string called prompt using the F string. So it tells the AI to clean up and improve the Python code stored in the code snippet. So the prompt specially asks the AI to return only the updated code. Next, the get chat completion sends this prompt to the selected GPT model using previously defined function. So this function calls the OpenAI API and gets a revised version of the code as a response. Finally, we are printing the GPT code, displays a new version of the code so you can review or use it. Lastly, this line sends the same prompt to a different model, the O1 model, using the get chat completion function. So this prompt asks the model to clean up and improve the code stored in the code snippet. The function processes the request and stores the model's response in the O1 code variable. So this response should contain the optimized version of the original code generated by the O1 model. The next line we are having print O1 code displays the improved code in the output, allowing you to see the and compare the O1 model's version with GPT model's output. This is useful for evaluating the differences in the code quality, clarity, and optimization between the models. Lastly, the result is stored in the result variable and then displayed using the display markdown result, which renders the output in the nicely formatted markdown, great for readability in Jupyter notebooks. In short, this step helps you to use the AI not just for generating code but also for doing a quick side-by-side code review and analysis as well. So let's now move on to the last module. Hello guys, welcome back to this last module. So let's now get into reasoning with images. We will start with importing the warnings, and this is a built-in warnings module which is used to manage the warning messages during code execution. The second line uses the warnings.filter warnings, to suppress all the warnings. This means any non-critical alerts will be hidden from the output. This is commonly done to keep the output clean, especially in the notebooks or scripts where you don't want warning messages to clutter your results. So we'll run this. So then here, the first line imports the JSON module which is used to work with JSON data. This is helpful for parsing, formatting, or storing structured information. The second line imports the OpenAI class from the OpenAI package. This allows you to connect to the OpenAI's API and make requests to generate the text, code, or other outputs from the AI models. Then the line from ipython.display import display markdown image imports tools to visually display the markdown text, images, or formatted output, commonly used in the Jupyter notebook. So after that, the code imports the get OpenAI API key function from a custom file named helper. This function retrieves your OpenAI API key securely, so it doesn't need to be hard-coded. The function get OpenAI API key is called and the return key is stored in the OpenAI API key variable. This key is needed to authenticate with the OpenAI API. The lines defining the GPT model, GPT-4o mini and the O1 model, that is O1, specify the names of the AI models you want to use for generating responses. So these can later be passed when making the API calls. Finally, client is equal to OpenAI creates an OpenAI client instance which you will use to send prompts and receive completions. So this should ideally be OpenAI API key, include the authentication unless your environment handles the key automatically. So we'll now run this. So this means the image is expected to be located inside a folder named data in your project directory. The second line uses display image file path to load and show the image in Jupyter Notebook or similar environment. It visually renders the organization chart image so you can see directly in your notebook output. So this is commonly used when working with the visual data or presenting diagrams, charts, or anything like that. So let's now move on to the next one. The code starts by importing the base64 module which is used to encode the binary data like image files into a base64 string format. This is necessary because APIs like OpenAI's vision models accept images as base64 encoded strings. The function encoded image, that is the image path, takes an image file path, reads it in binary mode, that is the RB, encodes it in using base64 and returns it as UTF-8 string. This prepares the image so it can be safely passed to an AI model in the required format. The main function O1 Vision is designed to send both an image and a text prompt to an OpenAI Vision enabled model like GPT-4o. It first encodes the image using the encode image function. So inside the function it checks whether JSON model is true or false. If JSON mode is true, the response will be requested in the structured JSON format using response format, type, and JSON object, which is useful for extracting the structured data from the model's reply. So if JSON mode is false, it simply sends the prompt and image together and expects a regular text response from the model. Both the versions use client.chat.completions.create method to make the API call. Finally, the function returns the raw response object from the API, allowing the caller to further process or display the model's output. In short, this function lets you send an image along with the custom prompt to a vision capable OpenAI model with an option to get the result either as plain text or structured JSON. So this line calls the O1 Vision function which sends both an image and a prompt to an OpenAI Vision model for analysis. So it passes three arguments: file path, that is image file path, to the image file, prompt equal to what is this. This is asking the model to describe the image, and then model is O1 model which specifies the vision capable model to use like O1. The function processes the image and the prompt, sends them to the model, and then stores the model's response in the variable response. So this response will contain the AI's interpretation of the image which you can later extract and display. So this line is used to display the AI model's response in a clean and readable format inside a Jupyter notebook. So this response dot choices 0.message.content accesses the actual text content that's generated by the model in the first response choice. So wrapping it with a markdown allows the output to be rendered with the proper formatting such as bold text, bullet points or headings if the response includes markdown syntax. Finally, display renders the format markdown content in the notebook output area, making the model's reply easy to read and visually structured. So let's now start with understanding the image. The code defines a variable called the structured prompt, which is a string that will be sent as a prompt to the AI model, most likely a vision-enabled one, to extract the structured data from an image. The prompt includes special instructions tags to clearly tell the model what to do. It says that the model is acting as a consulting assistant where job is to process organization chart data from the image. So if then specifies the desired output format, a JSON structure that includes an arbitrary ID for each person, their name, role, an array of IDs they report to, and an array of IDs that report to them. So this is a clean and structured way to actually represent an organization hierarchy. So finally, we are printing the structured prompt, says the full prompt string, so you can review or verify its contents before using it as a function like the O1 version. So this code calls the O1 vision function to send both an image and a structured prompt to the OpenAI vision model. This is the O1 asking it to extract the organizational hierarchical data. The arguments passed include file path equal to image file path, which points to the organization chart image, model is equal to O1, specifying the model to use. Then we have prompt is equal to structured prompt, which contains the detailed instructions on the output format, and the JSON mode is equal to true. Setting JSON mode equal to true tells the model to return the result in a structured JSON format. So instead of plain text, making it easier to parse and use programmatically. The final line actually prints the model's JSON formatted response from the first message choice, which should include the organization structure with IDs, names, roles, and reporting relationships. You can see the output. So this line creates a new variable called the clean JSON that stores a cleaned up version of the model's response. Sometimes when the models return the JSON code, they wrap it in markdown formatting using the triple backtext like JSON and to indicate a code block. So this line removes those wrappers using dot replace and dot replace with inverted commas, leaving behind only the raw JSON content. The result is a plain JSON string that can now be parsed or processed further without formatting the issues. So this line attempts to parse the model's response directly using the JSON loads, which converts a JSON formatted string into a Python dictionary order list. So it accesses the O1 response.choices.message.content, which is expected to contain the JSON output describing the organization chart structure. The result is stored in the variable that is the organization data, making it possible to work with the organization hierarchy as a structured Python object. However, the JSON file still contains the markdown wrappers like JSON. You should use previously clean version instead for space parsing. So the code defines a new prompt string called the analysis prompt, which is meant to guide an AI model to answer questions based on a previously extracted organization chart. It starts with the special instructions like you are an organization chart expert assistant. Your role is to answer any organization chart questions with your organization data. And we have given the instruction. So this tells the AI what role it plays and how to use the data. Then it embeds the structured organization chart data inside organization data tags by using an F string. This helps the model clearly understand that this is the data it should reference when generating answers. So let's now run this. Here in the code, the first line is importing the get OpenAPI API key. This function is typically used to securely retrieve your OpenAPI key without hard coding it in the script. The second line calls this function and assigns the result, that is your API key, to the variable OpenAPI API key so it can be reused throughout your code for authentication. Finally, the client is equal to OpenAI creates an instance of the OpenAI client using that key. This allows you to send the prompts and interact with the OpenAI's models through authorized API calls. So as discussed before, these are the messages and the role user content analysis report plus who has the highest ranking reports and which manager has the most reports. And we will just run this. So then we are finally displaying the markdown, allowing my markdown formatting like bold text, bullet points or headers to be properly displayed, rendered. And the first line sets the variable image file path to the path of an image file named as erdrelationorder.png, which is located inside a folder called data. So this image likely contains an entity relationship diagram. The second line uses the display image to load and visually display the image with the Jupyter notebook. So we'll just run this and basically you can now see the output, the product ID, this is the order, product, this is the ID, the client, it also has a ID, CID, product name, client address, product price and client credit card. So basically this was all about the course. That's it. So congratulations on completing your journey with Reasoning with O1. You have gone from understanding the core foundations, what Reasoning with O1 is, why it's crucial in today's AI-driven world and where it can be applied, to actually putting it into practice. We began by setting the stage with the fundamentals, then moved on to hands-on exploration, crafting effective prompts, practicing logical and structured reasoning, then writing and refining code with O1, and finally understanding how each layer builds towards the AI interaction. You didn't just learn the theory, you experienced it through demos, challenges, and the real-world examples. So whether it was decoding logic, guiding AI through structured thought, or debugging your own process, you have now got a strong grip on how to think with AI, not just about it. This is just the beginning, guys. Keep experimenting, keep questioning. The more you reason, the smarter your results become. Thank you for watching.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.